now that we've looked at the unit circle, we want to see what else is on there. We've talked about secant, cosecant, cotangent. How do those things tie into the unit circle? So let's do a quick review. First, of sine and cosine. This is what you did back in section 4.2. You had your unit circle, and you had some sort of angle measurement, and you knew that the hypotenuse always had a radius of 1 on the unit circle. And what we saw was that we can create a reference triangle inside the unit circle where the x value indicates the cosine and the y value indicates the sine. And when you look at that, you can see that the cosine and the sine values are always going to be between 0 and 1, since we've got a right triangle there, and the hypotenuse has to be 1. So let's take it one step further now. Let's look at a relationship of tangent and another trig function. Over here I say the tangent is found by creating a tangent line to the x-axis. So I'm going to draw another unit circle over here. And we're going to draw a tangent line. Remember from geometry, a tangent line only touches the circle once. So if it's going to go through the x-axis, it's got to go through the point 1, 0. So there's a tangent line. Now the tangent value is the length from the x-axis to where the angle would intersect the tangent line. So let's say my angle measurement is right here. And there's my theta. If I were to extend this angle back, I can say I get a point of intersection right there on the tangent line. The tangent value is the distance from the point 1, 0 up to that point of intersection on the tangent line. So that value indicates the tangent. Right here, this piece we know has a length of 1, and now my reference triangle ends up being the side of 1 here, this tangent length, and then going all the way back down from the intersection point back to 0. And that value ends up being the secant. So tangent and secant are going to be tied together on the unit circle. So right there, the secant is formed by extending the hypotenuse of the triangle until it intersects the tangent. Ooh, right there. So let's look at one more then. The last one then is going to be the cotangent, and the other trig function we haven't talked about yet is cosecant. So these guys are going to be together. And it's going to be taking the exact same thought process that we used on the previous problem, only we're going to extend it to the y-axis. So here's my unit circle. I'm going to create a tangent line that goes through the y-axis. And if I've got my angle measurement, I extend my angle line back. Right here on the y-axis now, I know that this value is going to be 1. The cotangent then is the distance from the point 0, 1 to the point of intersection. And then finally, if I extend the hypotenuse back, this value ends up being the cosecant. Now, question number 5 I asked off to the side. What Pythagorean relationship can you come up with? And we can come up with a Pythagorean relationship for every single one of these triangles. We know from geometry the Pythagorean theorem is x squared plus y squared is equal to the radius squared. So let's look at that from each one of these diagrams. The first one here is sine and cosine. And we know x values are cosine, y values are sine. So for the first one we've got cosine squared plus sine squared, and here the radius of my reference triangle is 1 squared, which is 1. The cosine squared of x plus sine squared of x is equal to 1. And actually, we could write that in terms of thetas, and I actually like that a little better. Cosine squared of theta plus sine squared of theta is equal to 1 instead of x's. Don't want to get confused with x's and y's. Let's call them thetas. And that's because I used this reference triangle right here. Cosine squared of theta plus sine squared of theta is equal to 1. We can apply that same thought process with this reference triangle that involves the tangent and secant. So if I look at my x piece, my x is going to be 1 squared, which is 1. My y value is tangent, and that's going to equal the long side, which we said was secant. The third identity then is taking my reference triangle from being over here. I've got the 1, I've got a cotangent, and I've got cosecant. So here my x direction here is cotangent. So cotangent squared plus 1 is equal to the cosecant squared of theta. So Pythagorean relationships you can come up with, or you can create Pythagorean relationships with all 6 of those trig functions. Now let's say you forget these pictures in your head. All you really need to memorize is the first one. Let's say cosine squared of theta plus sine squared of theta is equal to 1, and I want to come up with one of these other two identities. I can divide through by either sine or cosine. So here, if I divide through by cosine squared over cosine squared is 1. Sine squared divided by cosine squared is going to be the tangent. And then 1 over cosine is equal to secant, which is how we get identity number 2. And if I were to do the same thing, but this time dividing through by sine, cosine over sine is the same thing as cotangent. Sine squared over sine squared is equal to 1, and then 1 over sine squared is cosecant squared. So then this right here is the same thing as number 3 right there.